G'day everyone, Luigi Renzullo here, welcoming you to week 8 of the Blue Planet course and today's lecture on climate indicators. Today we're going to cover the concept of anomaly. We'll talk about how we use anomalies to see how far a system's behaviour differs from what we expect and how we can use that to interpret extremes. We'll talk about some of the key ocean indicators you'll encounter in interpreting the drivers of Australian climate and when these indicators interact to give us some of the crazy weather we unfortunately see more and more of these days. To begin with, however, a bit of a somber note. It's no exaggeration, I think, to say that we've just lived through one of Australia's worst ever fire seasons. The extent of the devastation, the intensity of the impacts has overwhelmed everybody. They say this is one for the history books, but they also say that the understanding of fire behaviour, the dynamics of the interaction between weather, climate and the fire has to be revised because there was a lot of stuff they just didn't know, didn't expect. And so, hopefully some good will come out of the last few months and the fires that we saw over the summer season. They say that those no one could have predicted the extent and the intensity of the devastation of those fires. But when we look at climate indicators, if we look at the times of year, we see some of these extremes in the value of their indicators. Perhaps they could have given us some forewarning. Similarly, if we look around at the drivers of Australian weather and deviations of the expected behaviour of Australian weather from the norm, can that tell us something in preparing for a future summer season? The key to understanding climate in Australia is really to focus on the role of our oceans. It shouldn't be too surprising that our oceans really do drive the climate we see in Australia. And of course, in the smaller timescales of the weather we experience. Right, so launching into this concept of anomaly. So Earth really evolves, develops, shapes over millions and millions of years, processes that take long geological, environmental timescales. And so Australia has learned to adapt to the weather it experiences from our oceans. When we get deviations from the normal or expected weather, that can have a big impact on the environment. And in relatively recent years, compared to the life of the Earth, human activity has exacerbated some of these changes. We talk about an anomaly as a deviation of a quantity from its normal or expected behaviour. And here's just an example of air temperature over the Canberra region. This is the average behaviour for each month of the year. I think these are monthly average air temperature values. Oh, beg your pardon. No, sorry, they are monthly average temperatures, but they're average daily for the Canberra region for 30 years. And you can see it is warm in the January, November, December, there's the summer seasons, and it dips around June to the minimum around July, deep into the winter here. Average air temperatures over the year. Any given year can have a deviation from the expected behaviour. In this case, we can see that the red curve is the average temperatures in each month for 2017. January seems to be a lot higher than the expected air temperature, and so to the October to December months. So a way of expressing this as a difference can sometimes highlight the deviations a lot better, or the departures from the normal expected behaviour. So we talk about the anomalies as the deviations from the expected behaviour and what that means. And what we want to monitor is if there's a persistence in the deviations through time. So what we saw was the previous plot was the time series for a location. We can, of course, extend this to the whole country and look at time series for each area of the Earth, the Earth indeed, but Australia through time. And here we've got the air temperature anomaly for 3 months of 2019, October, December. And they are deviations from the 30-year average between 1961 and 1990. This is the current 30-year average, is the reference period for a lot of the climatological anomaly things you might hear in the news or in scientific literature. What you'll notice, hopefully, is that there's very few, well, there's no parts of Australia except perhaps the northwest corner of Tasmania that isn't above the, didn't experience a temperature above the average. So pretty much all of Australia in the last 3 months of last year was pretty much above average temperatures. Sometimes the anomaly is a nice way to see the deviation, how the deviation of any given year departs from the expected behaviour over a reference period. What we can also generate is these decile maps. What these do is they rank the current conditions in the whole, taking the whole historical period. So the idea is that for every cell across Australia, a model cell, we rank the temperatures from their lowest value ever, the record, and that goes about 115 years currently, 120 years nearly. You rank them from the lowest to highest at each point on the landscape, chop the interval, the range up into 10 equal sized bins, and then you can see where the current conditions, which bin the current conditions fall in. And so what you see when you do that, you see that the January, the mean temperature for the whole of 2019 ranks for very large parts of the country, central Western Australia, large parts of New South Wales, southeast Queensland, and just generally Australia is in the above average and very much above average range, top deciles. I think this is a really neat way to illustrate where current conditions rank in the historical time series. Right, so focusing a bit on 2019, when we look at this decile mapping on the left of temperature and on the right of the rainfall, on the left, let's see, it's all of Australia is pretty much above average and very much above average. Similarly, in the rainfall decile map on the right, there, in terms of recorded rainfall, most of the country is below average, with many parts very much below and lowest on record rainfall measurements. Queensland got a bit of rain in the middle of the year, so that sort of brings that area above average. But generally, it was the hottest and driest year we've experienced in the recorded history. And of course, for more information on this, we can go to the Bureau of Meteorology for their climate synopsis reporting. We're very lucky to have this resource in Australia, where we can, Australia has the Bureau of Meteorology as the custodians of all our weather and climate information, and part of their mandatory role under active law is to give these data available to researchers and the public. And so here they present climate records going back 120 years, maybe a little bit more, for some parts of the country. and it's a wonderful resource that I'm sure most of you will encounter time and time again in your research careers. So yeah, do have a look at the website.